So your 4.3 lesson goes over your properties of logs. The first thing that we're going to look at is working with your change of base formula. What this means is that when you're taking the log with a base of a number that you can't raise that base to a power to get that number, you're going to take your calculator and use log of the big number divided by log of your base. So the subscript number is your base. So if we look at some examples, which we have a lot of, for A, we have log 4 of 25. You cannot raise 4 to a power to make it 25. So that means that we're going to use the change of base formula, and in our calculator, do log 25 divided by log 4. So this should give you 2.3219, so on. If we round to 3 decimal places, that would be 2.322. For B, we have log 3 of 17. Again, you can't raise 3 to a power to get you to 17, so we're going to do log 17 over log of 3. So we plug this into our calculator, we round to 3 decimal places, we should have 2.579. For C, we have log 4 of 8, so we're going to take log of 8 divided by log of 4. This gives us 1.5. D gives us log 9 of 27. So again, we're going to do log of 27 divided by log of 9. And this gives us 1.5 as well. E gives us log 8 of 16. So again, we're going to do log of 16 divided by log of 8. We plug this into our calculator, we get 1.3 repeating. If we're rounding to 3 decimal places, that's just 1.333. For F, we have log 5 of 300. So again, we're going to do log of 300 divided by log of 5. If we round to 3 decimal places from what our calculator gives us, this is 3.544. For example G, we have log 12 of 24. So this one we're going to do log of 24 divided by log of 12. Round to 3 decimal places, and that gives us 1.279. For H, we just have log of 500. You could just type this into your calculator. If you didn't know that you could do that, you would still be able to do log of 500 divided by log of 10, because it's understood that that base is 10. So this one, rounded to 3 decimal places, would be 2.699. The next part that we're going to look at works with the properties of logs. You have a couple different ones, some that you've seen already. The first one that we're going to look at is the multiplication. You can interchange multiplication with addition. Okay, so whenever you see 2 terms being multiplied after the log with the base, you can separate those 2 terms, or more than 2 terms, with addition. Division is interchangeable with subtraction. So if you have the log base of something over something, it's the same exact thing as saying log base of something minus log base of something. Okay, and then what you've seen already is when you have the log base of a number raised to a power, that power moves to the front of that log. So if we look at some examples dealing with these properties, the first one that we're going to see here is the addition. So we're going to interchange the addition with multiplication. A couple things you got to make sure that you look at here is make sure your base is the same for both parts. If it's not, then you can't use this method. You can't use this property. Okay, so for example A, you're given log 4 of 2 plus log 4 of 32. So that just means we have log 4 of 2 times 32. If we can simplify here, we're going to. This means that 2 times 32 is 64, so that's log 4 of 64. 4 is raised to the 4th power, no, sorry, 4 is raised to the 3rd power to get you to 64. So 4 cubed is 64. Simplified fully would be 3. For example B, you have log 5 of 625 plus log 5 of 25. These both have a base of 5, so we're going to rewrite it using multiplication. So that means that we're going to have log 5 of 625 times 25. That 625 times 25, you could multiply it. You would get 15,625. If you didn't, you see that the base here is 5. You could just find the factors of 25 and 625 using the 5 to see what that 5 is raised to in order to get your answer. So that 25 is 5 and 5. That 625 is 5 times 125. 125 is 5 times 25. And 25 is 5 times 5. So that's a total of 1, 2, 3, 4, 5, 6 times. So 5 to the 6th power is the 625 times 25, which means that answer is 6. For your next example, C, you have log 1/3 of 27 plus log 1/3 of 1/9. So this is going to be rewritten using multiplication. So you have log 1/3 of 27 times 1/9, which is the same thing as 27 divided by 9. So that's log 1/3 of 3. 1/3 to what power is 3? Well, that's just -1. So the power of -1 is your answer. For something like example D, where you have log A of 3 plus log A of 4, again, we rewrite using multiplication. So that's going to be log A, not 9, A of 3 times 4, which is log A of 12. A cannot raise to a power to give you 12, so you're going to leave it in this form. Your next section goes over the properties with subtraction or division. So subtraction is interchangeable with division. So anytime you see these problems with the same base and it's separated with subtraction, you can rewrite using division. So for A, you have log 2 of 32 minus log 2 of 4. You have subtraction there, so represent that subtraction with division because your two bases are the same. So that means you're going to have log 2 of 32 divided by 4, which is log 2 of 8. 2 is raised to the 3rd power in order to give us 8. So simplified is the 3. For B, you have log 7 of 49 minus log 7 of 7. So again, you have subtraction here, which we're going to rewrite using rewrite using division. So you're going to keep the log 7, just do 49 divided by 7. That gives you log 7 of 7. We said in the section before this that when your base is the same as your whole number part, they cancel out, so it is just 1. For C, you have log A of 7 minus log A of 5. Your bases are the same. These are separated with subtraction, so we'll rewrite it using division. So this is just going to give us log A of 7 over 5. Again, A can't be raised to a power to give you the 7/5, so that is your answer. And for D, you have log 4 of 64 minus log 4 of 16. Again, bases are both 4. Separated with subtraction, we'll write using division instead. So that gives us log 4 of 64 divided by 16. This does simplify to give you log 4 of 4. Again, your base is the same as your whole number, so these cancel to give you 1. Your next part goes over when you have powers on your whole numbers or simplifying using your powers. For A, you have log 8 of 8 to the power of 3x plus 1. This 3x plus 1 has to be moved to the front because it's a power. So that's 3x plus 1 times log 8 of 8. We said in the section before this, when your base is the same as your whole number part, it cancels out and becomes 1. So that's just 3x plus 1 times 1, which is 3x plus 1. B is a little bit more difficult. You have log 5 of 125. So you could ask yourself, 5 to what power is 125? However, the 125 is the same thing as saying 5 to the third power. So this can also be written as log 5 of 5 to the third power. We know that that power goes to the front, so it would become 3 times log 5 of 5. We also know that when our base is the same as our whole number part, the whole thing becomes 1. So that's 3 times 1, which is just 3. For example, C, you have 2 to the power of log 2 of 27. For this one, your base is the same as the base in your power, so those will cancel, become 1, and you are just left with the 27. For example, D, you have log of 10 to the power of 0.9. That log of 10 has a base of 10. We know that that power goes to the front, so it's 0.9 times log 10 of 10. Base is the same as the whole number part, so this becomes 1. So it's 0.9 times 1, which is just 0.9. E and F are just like C, where you have your base that's raised to a power with the same base on the log as your base. So for E, you have 4 to the power of log 4 of 8x. That 4 cancels out the log 4, and you're just left with the 8x. Same thing for F. You have 3 to the power of log 3 of 452. This 3 and the base on the log are the same, so they cancel out, and you're just left with the 452. So with this example, you have the natural log of 6 and the natural log of 2 over 27. It tells you to write each log in terms of ln2 and ln3. Well, if you look at example A, that natural log of 6, 6 is 2 times 3. So that means this is the same exact thing as saying the natural log of 2 times 3. We said in the sections before this that multiplication can be represented with addition. So that would just be the natural log of 2 plus the natural log of 3. B is a little bit more difficult because you're working with a fraction. With this one, you have the natural log of 2 over 27. Well, 2 over 27 is the same thing as saying the natural log of 2 times 1 over 27. However, the 1 over 27 is not in terms of 2 or 3. 27 is 3 to the third power, but we have 1 over 27, so that means that this would turn into the natural log of 2 times the natural log of 3 to the negative third power. So that would give you the reciprocal of 3, and then that 3 will be raised to the third power to give you the 27. So from here, your multiplication can be represented with addition. So that's going to give us the natural log of 2 plus the natural log of 3 to the negative third power. That power of negative 3 is going to go to the front of that natural log. So that's going to give us the natural log of 2 plus negative 3 times the natural log of 3. The plus and the minus next to each other has to simplify. So that's going to give you the natural log of 2 minus 3 natural log of 3. Your next section tells you to use the properties of logs to expand the expression. So with these, you're rewriting multiplication using addition and division using subtraction. Remember, powers go to the front. So for A, you have log 4 of 5x cubed y. We have multiplication here and here, so we're going to separate using addition. So remember, you're going to keep the log 4 with every term. So we have log 4 of 5 plus log 4 of x cubed plus log 4 of y. You have a power on one of these, and that power has to move to the front. So that 3 on that x as the power is going to go in front of that log 4 of x. So that's going to give us log 4 of 5 plus 3 log 4 of x plus log 4 of y. For example B, you have the natural log of the square root of 3x minus 5 over 7. Now, this fraction is the same thing as division, which we can represent using subtraction. So this is going to give us the natural log of the square root of 3x minus 5 minus the natural log of 7. That 3x minus 5 is underneath your square root. The square root is represented with the power of 1/2 because your index here is 2, and this is all raised to the first power. So we can rewrite this as the natural log of 3x minus 5 to the power of 1/2 minus the natural log of 7. Once again, your power has to move to the front of that natural log. So that's going to give you 1/2 times the natural log of 3x minus 5 minus the natural log of 7. So for your last 3 examples, it tells you to use the properties of logs to condense each expression, which means you're going from the long form to the shortened form. So again, we're going to represent addition with multiplication, move those numbers from the front to be powers, and if there's subtraction, use division. If we look at the first example, we have 1/2 times the log 10 of x plus 3 log 10 of x plus 1. First thing you're going to do is take that 1/2 and pull it to be the power on that x. So that means you're going to have log 10 of x to the power of 1/2, and that's going to be added to the 3 that goes to the power. So that's log 10 of x plus 1 cubed. From here, you cannot leave powers as fractions. So that 1/2 power has to be rewritten as the square root. So that means you're going to have log 10 of the square root of x plus log 10 of x plus 1 cubed. Now you have addition between these two parts. So we are going to rewrite with multiplication. So that's going to give us log 10 of the square root of x times x plus 1 cubed. Do you need the base of 10 on this log? No, but if you want to keep it, there's nothing wrong with that. For example B, you have 2 times the natural log of x plus 2 minus the natural log of x. We're going to first take this 2 and bring it to be the power on that set of parentheses. So you're going to have the natural log of x plus 2 squared minus the natural log of x. You have subtraction that separates your two parts here. So we're going to rewrite that using division. So you're going to keep the natural log. Up top, you're going to have x plus 2 squared. On the bottom, it's just going to be x. So that's the natural log of x plus 2 squared over x. You have 1/3 log 2 of x plus log 2 of x minus 4. We're going to do what's in the middle first, or the inside first. So represent your addition with multiplication. Just focus on that so far. You're going to have log 2 of x times x minus 4. Now, this whole thing is not the 1/2. It's being multiplied by the 1/3. So that power goes on the top of here. So think about it as if you were to factor or FOIL this in, or distribute that in. You'd have log 2 of x squared minus 4x. And this would be what's raised to the 1/3 power. So that means that you're going to have log 2 times the cube root of x times x minus 4.